today we can able to finish the slides. Yeah, let me share my screen. Okay, so let's refer back to our last question, the last questions that we discussed yesterday. Okay, can I have any students unmute the mic and let me know that you can see my screen, the whiteboard?
Yes, Miss.
Yes, Miss.
Okay, so okay, yesterday I think there's an error on this part, so for the calculation, so I'm not sure the rest whether realize or not. So I just double check, it's supposed to be negative 21.58, okay, so it's supposed to be 5, okay, not 2. Okay, then it will affect our answers here, so here also 5, 8. So we have 33.01 still remain the same answer. Wait, hold on. Check again. Oh, sorry, 33.21. Okay, 33.21. Okay, 33.21. So it will also affect the answers here. So here should be 5. Okay, so it should be 40.53. Okay, then it's also affect the answers here. Okay, so it should be 0.53. Okay, so slightly affect the answer. Okay. Okay, thanks to Samuel. Okay, so okay, anything? Okay, so I think done. Okay, but yesterday I haven't finished all these questions. Okay, so I just picked the questions for A and D. Okay, so how about the rest of the students? How do you think the questions B and C, is that okay? So because I can see the way to solve the questions is almost the same. Do you have any question? If you have no questions on the other two tutorial questions, what I mean is I have done A and D, right? So for B and C, is that okay? Okay. If let's say no issue, then I will continue the lecture. So if you have any questions, you can put it in the chat box. Okay, the 7B and C, is that okay, students? I gave the answer already, is it? I gave, right? Yeah, I remember I gave. Okay. So far I don't see anything in the chat box. Okay, about the same answer. Sometimes it's just a rounding error. Okay, then if that's the case, if no requirement on discussing those questions, then I'm going to continue with the lecture. Okay, and for your information, next Tuesday we have a holiday. So this week is week 11. Suppose next week is week 12, our last week. Time flies, huh? Okay, so but 19, which is next Tuesday, is a holiday. So next week, our last class seems to be on Monday. Okay. So okay, let's see how's the progress today. Okay, hold on. Saad asked me to discuss 7C. Okay, can, not a problem. Okay. So For next Tuesday, there's a holiday on next Tuesday. There's a holiday, so I will next week only see you on Monday. So let's see how's the progress today. Huh? Okay, so because I would like to include the discussions for the exam. So I think within this week, I will upload sample exam question and also some extra revision questions for exam, okay? So that if let's say not the holiday, I think we can have a revision on exam next week. We'll see how is it, okay? In case we need the extra class, we'll let you know, okay? Let's see how is it. Okay, so upon the requirement by Saad, discuss 7C. Okay, let me copy these questions to the whiteboard. Okay, so I open a new whiteboard. Okay, so for question 7C, right, there are 3 forces here. Okay, so I'm not sure whether you can see it clear. The force for A, right, is from here to here with 140 degree, and for the force of B is 190, and for the force of C is 290 degree. Yeah, okay, that's it. Okay, 3 forces here. Okay, so you already, can you see these questions? You already identified the angle from the positive x-axis. Okay, so we can start for the calculations here. Okay, the forces. So we have first one, forces all in Newton. Okay, so for the force of A, so that is 22 Newton, B is 40, and C is 15. Okay, then let's start with the horizontal component. Okay, so for A is 22, right? So as I say, you just calculate as a cos 140 degree. So for B is 40, so 40 cos 190. And the third one is 15 cos 290. Okay, then let's calculate. We get a negative 16.85. Second one, negative 39.39. And the third one, 5.13. Okay, let's add it up. Okay, so we have a negative 51.11. Okay, so this is my total horizontal component. Okay, let me double check with my answer. Yes, it's the same. Okay, let's continue with the vertical component. So basically, you just change the cos to sine. Okay, so 22 sine 140, 40 sine 190, and 15 sine 290. Okay, now let's calculate. 14.14 negative 6.95. Negative 14.10. Negative 6.91. Okay, negative 6.91. Okay, slightly, I think slightly different with the answers I given yesterday. Okay, so due to the rounding error. Okay, so next one, calculate for the R, the magnitude. Okay, 51.57. Then for F, arctangent of 6.91 divided by 51.11. Okay, so we got 7.70. Okay, okay. So now, may I know what is the quadrant? Saad, what is the quadrant? Which quadrant? Both negative? Fourth, yes, okay. Horizontal negative, vertical also negative, so fourth quadrant. That means 360 degree minus 7.7. So which is 352.3. Wait. Oh, yeah, correct. Okay. Horizontal negative, vertical negative. Yes, third quadrant, not fourth quadrant. Okay. Okay, so third quadrant, that means 180 plus 7.7. So 187.7. Okay. Yep, should be third. Okay, Saad, do you understand how to get third quadrant? Because there's a few times you are answering wrong for the quadrant when I'm asking you. So do you really understand? You follow like a coordinate system. Okay, you follow like the coordinate system. So like a horizontal axis and vertical axis. For horizontal, when it's negative, that means when horizontal, that means it's like the x. When x is negative, vertical is like the y. So when y is also negative, which quadrant? Yes, okay. Then the careless mistake. Okay, then you have to be careful. Okay. So 187.7. Okay, third quadrant. Then, yep, correct. Done. Okay, so Saad, is that okay? the discussion of this question. Okay, slightly different with my answer yesterday. Just because of the rounding error. I think the answers I gave you yesterday, I directly calculate from the sine and cos. But here I'm showing you 2 decimal places. Okay, so okay, then done for the discussion of C. Then I should proceed to the slide. Okay. So previously we stopped here. Okay. Then today we will move on to the vectors in 3-dimensional. Okay, so previously we have the discussions on our vector is all 2-dimensional. Okay, and when come to vectors in 3-dimensional, okay, remember when come to 2-dimensional, so that means we just involve the x and y axes. Okay, 2-dimensional. So for any, for example, this one is 3, this one is 2, right? So I can write this vector, let's say this is 3, this is 2. I can write the vectors as 3i plus 2j. Okay, I can write the vector as 3i plus 2j. So now what makes a difference if come to 3-dimensional? So when come to 3-dimensional, right, you can see other than x and y, we have z additional axes. Okay, previously only 2 axes, but now we have 3 axes. Okay, additional one is a z. Okay, so for for x and y, we're using the I and j. So when come to the additional axis of z, that is representing by k. So x, y, z plane. Previous one we only have x, y plane. For 2-dimensional, we have x and y plane. So when we have 3-dimensionals, then we have x, y, z planes. So which they are all orthogonal to each other. So when come to x and y, they are also orthogonal to each other. What it means by orthogonal? Means perpendicular or 90 degree to each other. So for x and y, they are 90 degree with each other. So when come to additional axis here, another plane, the z also 90 degree to each other. Okay, so you can see this is 90 degree, 90 degree. Okay, and 90 degree. Okay, now I, j, and k, okay, are unit vectors in the x, y, z direction. So previously we only have I and j, but now with the 3-dimensional, we have another one which is k for the z direction. Okay, so that means we will represent a vectors as a ai plus a1i plus a2j plus a3k. Okay, so this is for the another vector. So 3-dimensional. Okay, for example, so let's say I pick a simple one. Okay, let me see how to show you this. Okay, so remember just now we put this as a vertical one as a z. So this one as a x, this one as the y. Okay. Okay, for 3-dimensional. Okay, so now, okay, let's say I have a point A. Which the point A is actually with the position of 1, 2, 3. Okay, so this is a position of 1, 2, 3. Okay, so the bracket is represent the position, like the coordinate. So when you have 2-dimensional, you're using the coordinate x and y to represent the position, right? For example, 1 and 2. So when come to 3-dimensional, okay, so that means your point will be in three values, right? Okay, so what is means by this 1, 2, 3? So which is x, y, z. Okay, now, so when we look at here, the x is 1. So let's say the x is 1 here. Then the y is 2. Y is 2, let's say, is here. Z is 3. So 1, 2, 3. Okay, so let's say this is 3. Okay, then how we actually sketch the point for A? Okay, where is the point of A? What is the vector of OA? What is the vector of OA? O means the origin to the point A, vector OA. Okay, so the vector OA will be x is 1, right? So I plus 2j plus 3k. Okay, so how we present it in this diagram? Okay, so the origin is here. Okay, O. Okay, so that means from the origin I go to 1, right? I go to 1. This is the direction 1. So then come to y. Y, that means 2 units from here. Okay. Then z is 3, so I go up 3 units. So that means this is a point for A. This is a point of A. So you have to try to imagine this is 3-dimensional. So that's how I actually get the point A. So your vector for OA, which is from origin to the point A. So this is a vector of OA. Okay. So if we want to see, okay, in 3-dimensional, so maybe I should draw a box to show you. Okay, so I'm trying to draw a box so you can see where is the position of the point. Okay, this is the position of the point, so you can see it clearly. Okay, so this is means the blue line is referring to the vector of OA. Okay, so for vector of the OA, right? Okay, we will represent as this bracket, different bracket. Okay. So you have to see what is the difference here. For points, we're using round bracket. For vector, instead of, we can write as 1i plus 2j plus 3k, or we can write as another bracket 1, 2, 3. Okay, so it's okay if you still just give you an idea lah. Okay, of course in the exam I won't ask you to draw this. Okay, but it just give you an idea what it means by 3-dimensional. And when you have a vectors from origin to the point A, OA, then you understand what is the vector referring to. Okay, can you understand so far?
Miss, can you explain the triangle again? I don't get it.
The triangle, there's no triangle.
Yeah, then the red color A1.
Okay, the red color. Okay, so can you see how I get this red color? Because I want to get the position of the A. So can you see, first you need to understand, X, Y, Z, there are 1, 2, 3. So I plot 1 on X axis, 2 on Y axis, and 3 on Z axis. So far, can you understand the 1, 2, 3 on each axis? Cheng Hao?
Yeah, can.
Can. Okay, so once we plot the 3 points, right, 1, 2, 3, then we would like to get the position. Okay, so when you want to get the position, you must start from the origin. Okay, start from the origin. So let's say now I'm using yellow. So start from the origin is here. So from the origin, can you see we go to X first? The first one is X. X is 1. So I'm going to 1. So because the 1 is here. Okay, then can you see when come to y, y is actually to the right for 2 units. So after I go to the position of the x, that is 1 unit, I go to the right hand side for 2 units. So please take note, here to here is actually 2 units because of the y is 2. Okay, then after that, right, okay, I need to represent the position for the z. So z is 3 units towards the top. Okay, so that means from the current position, I'm going up for 3 units. So actually this part is actually 3 units. Then I get to this one. Okay, so since this is in the dimensional, 3-dimensional, so I try to use a box to show you where is the position of the A. Okay, so this is the position of the A. So now I draw a lot already, so I'm not sure whether it's clearer or even worse.
Yeah, miss, it's clearer. Thank you.
Okay. Now answering questions from Samuel. For cubic graph, do we just draw a line or should we draw the partial lines to show the box too? Samuel, are you referring to this 3-dimensional, the one that I'm showing here?
Yeah, yes, miss.
Oh, okay. So suppose you can just draw the line, okay? But most of the time when we want to present the position in the 3-dimensional, so we're using the box to show the 3-dimensional, because when we draw here, you just see something's plane, a plane, right? So you can't see the dimensional. So actually, we just draw the box to show it clearly. But don't worry about this one. As I say, I'm not going to require you to draw this. I just want you now, okay, whether you can understand where is exactly the position. So because you need some imagination on the point in the 3-dimensional, okay? So that's why I'm trying to show the box to show you where is the point in the 3-dimensional. But doesn't matter, okay? With the box or without the box, doesn't matter, okay? Okay, Samuel? As long as you can see, you can visual. Where's the point A now?
Yeah, miss.
Okay, then it's good. Okay? Okay, any other question before I move on? So actually the slide is not too emphasized on this one, but I found that if I don't really explain this, right? So students, when come to later part, they have no idea how's the vector in the 3-dimensional, okay? So that's why I try to explain a little bit more to you. Okay, so now this is our vector in 3-dimensional, which is represented as a A1I plus A2J plus A3K. Okay, so then, okay, there are some other terms, unit vector. So the unit vector for a vector A, right? Okay, unit vector, we're using a cat as a symbol. Okay, if you want to represent notation, the notation for unit vector of a vector A means on the for the vector A on the top, you just put a cap, okay? Then it is equals to the vector A divided by the magnitude of the A. So with the two straight line, it means magnitude. Okay, magnitude of the vector A. So what is the magnitude of the vector A? So what you see here, this is the magnitude of the vector A. Okay, how we calculate the square of each component, the square and addition of each component, okay, of the ijk, then it is the magnitude, or we say the length. So as I told you before, when come to vector, the magnitude is represented by the length of the vector. Okay. Okay, so now this is, for example, we have vectors of 2i minus 3j plus 3 plus k in 3-dimensional. So how you find the unit vector? So as a unit vector given, it is a vector divided by the magnitude. So let's count the magnitude first. Okay, so that means here you are calculating the magnitude of the A. So can you see we have 2, so 2 square. Then we have -3 square. Then K means 1K, so 1 square. So you total up and you get square root of 14. Okay, then the unit vector is equals to the vector divided by the magnitude. Okay, so this is our answer for unit vector. Okay. Okay, next one. Okay, next one is about the scalar product or dot product. Okay, so there's an operation for vectors, so which we call it as a scalar product or dot product. So what you can see here, this one we call it as a dot product or scalar product. Okay, so how we actually okay, this one is a formula which is involved the angle. So this one I come to you later. Okay, so okay, how we actually find the dot product? Why dot product? We also call it as a scalar product. Okay, for example, so let's say we have two vectors. Okay, so let's say we have two vectors. Okay, vector A, let's say I plus 2j plus 3k. So vector B, which is let's say 2I minus j plus k. Okay, just a simple one. Okay, so what is means by the dot product? Okay, dot product means the multiplication of the values for each component. So for example, when we start from I, so for vector A, we have 1I, so which is 1 multiply with the, for B, right, the component for I is 2. Okay, 1 multiply with 2, okay, then plus, okay, come to J component. So A, we have a numbers of 2. For B, we have -1. Okay, then plus, next one come to component K. So for A, we have a 3. For B, we have 1. Okay, so now we have 2 minus 2 plus 3, which is equals to 3. So this is how we calculate the dot product. So when come to the calculation of the dot product, you will get a value. So that's why they also call it as a scalar product. Okay, so because when come to the product of two vectors, okay, you don't actually get the vector, but actually you get a value. So since you get a value here, so that's why dot product, we also call it as a scalar product, okay, because you get a scalar. Okay, so that's how we conduct the dot product. Okay, okay, let's move on. Okay, so now for the dot product, right, it is also equals to magnitude A times magnitude B times cos theta. Okay, so what is a theta here? The theta is actually referring to the angle between the two vectors. So now we are taking vector dot product for vector A and product vector B. So for example, this is your vector A. So maybe this is your vector B. Okay, the theta which is referring to the angle between the two vectors. Okay, that is a theta. So according to the formulas here, okay, dot product for two vectors is also equals to magnitude A times magnitude B divided times cos theta. And if I rearrange this one, okay, I can able to get this. Okay, I managed to get this. And for the cos, that means cos theta equals to dot product for AB divided by magnitude A times magnitude B. And if you wish to find the angle, that means the theta between the two vectors, then it will be the arc cos of this formula. Okay, so that means this is a formula to find the angle between two vectors. Okay, This is an angle between two vectors, okay? Okay, now, so, okay, to me, this is not that important, okay? Okay, so, but just a quick one. Okay, so can you see when we have the I product I, so can you see the I is referring to the unit vector of the x-axis, okay, x-axis. So when come to I, they are actually parallel to each other, right? Parallel. So when parallel, that means the angle is actually 0. So remember, cos 0 always give you 1, and cos 90 degree is always give you 0. Okay, so when you have a dot product for I, JJ, and KK, right? Okay, you will always get the answer that is equals to 1. Okay, equals to 1. Okay, so because the angle between two of them are 0. Okay, so since they are on the same axis, right? Then for I and J, J and K, K and I, remember just like I say, all the three axes are orthogonal to each other, right? They are orthogonal to each other. So since they are orthogonal to each other, so when you get the dot product, right? Okay, because of the cos 90 give you 0, so you will always have a 0. Okay, so actually here is telling you something. Okay, so if let's say the dot product of the two vectors is actually giving you a values of 0, that means the vector A and B are orthogonal. Means 90 degree. Okay, so if let's say the dot product of the two vectors is a 0, that means they are orthogonal with each other. Means the angle between two vectors are 90 degree. Okay. Okay, so here showing you how we do the calculation for dot product, and I already explained it just now. So can you see we are taking the component for each x, okay, component for I multiplied with the component for I. Okay, so component for J multiplied with the component for J. Then component for K will be multiplied with the component of K. And then we take the sum. Okay, that is a dot product. Okay, so guys, can you understand how to find the dot product? Can you understand how to find the dot product?
Yes, miss.
It means it's kind of similar to matrix multiplication.
Is it the same? I can't say it's same as a matrix multiplication.
It's a bit similar.
Okay. I don't know. To me, I don't think so lah. Okay. Because matrices we have a rows and column. Okay. So doesn't matter. Okay. So we have another example. So the A and also B, vector A and vector B. Yeah. So let's say A, we have 3i minus 2j plus k. B is a minus I plus 3j minus k. So as I say just now, when you want to find the dot product, we just take the product of each component. So 3 times negative 1. Don't forget the negative. Okay, then for the second one is negative 2 times 3. Okay, then for the third one is a 1. K means it's a 1. Then here is minus 1. Okay, so you multiply and then you get the product for each of them, and then you take the sum. So we have negative 10 here. Okay, so this is a dot product. Okay, how we actually find the angle between the two vectors here? Okay, remember this one is the formula that I showed you just now. So the theta is actually arc cos of the dot product for the two vectors divided by the magnitude of each vector. So for the dot product, just now we already obtained as -10. Then how about the magnitude A and magnitude B? Okay, how we find the magnitude A? So magnitude for vector A, so remember, is the square root of the sum of square for each component. So for A, the component for I is 3, so 3 square. For J is -2, so square. Then for K is 1, so 1 square, right? So 3 square 9 plus 2 square 4, 13 plus 1, so square root of 14. Okay, then when come to the magnitude of B, right? Okay, so can you see B, we have a -1 for I, so -1 square. Then second one is 3, so 3 square. Third one is -1, -1 square. So -1 square is actually give you 1. So 1 plus 1, 2, 2 plus 9, which is 11. So this is square root of 11. Okay, then we substitute here. Okay, then we calculate and we get 143.7. Okay, guys, I want you to try to calculate. Okay, can you get 143.7? I give you 30 seconds. Try to do the calculation. Whether you can get 143.7. Okay, guys, can you get 143.7?
Yes, miss, I got it.
Okay, you got it, huh? Okay, good. Because this is online class, I can't see whether you all calculate or not. Okay, so you all have to practice. Anyway, when come to tutorial questions, I think we do have this kind of question. Okay, got it. Good. Okay. Okay, so you need to practice. Okay, so then next we come to an applications on the dot product before we continue for cross product. So when come to vector, we have dot product, we have cross product. Okay, two types of the product. So when come to application, okay, one of the applications of the dot product is to the work done by a constant force when moving a body. Okay, so the work done is the product of the applied force. Okay, so and the distance move in the direction of the force. Okay, so when come to the work done, the formula is actually given as a force dot product of the force and also the direction of the force. So please take note, these two are the vector. So this is the dot product of the vector. Okay, so let's have a look with the examples here. Okay, so let's say we have questions here. Okay, which is there's a vector of the force given as 10I plus 2J minus K. Okay, displaces an object from A to B. Okay, in meter. So find the work done in Newton. Okay. Okay, so now, okay, you need to find the distance moved in the direction of the force. Okay. So it's a, can you see the formula just now is a product of the applied force. So this is a F, and then the distance moved in the direction of the force, so which is the D, right? So we need to calculate the direction, which is moving from A to B, right? So that means you need to find a vectors of AB. So this one is a vectors of AB. Okay, so how we find the vectors of AB? Okay, this one I need to explain a bit. Okay, now, okay, so according to here, right? Okay, let's say this is the vector B. Okay, this is a position. This one is a position. So from the origin of the O is a position of 0, 0, 0, to the vector A, so to the point B. So the line from the origin to the point B, so this line is the vector for OB. Okay, the vector for OB. Okay, please take note about that. Okay, of course, this is in 3-dimensional. Okay, okay, then let's say we have another point A. So let's say point A is actually with the position of 1, 1, 1. Okay, then from the origin to the point A, okay, is a vectors of OA. The line from O to A is a vector of OA. Okay, so now you need to find the vectors for AB. Okay, vectors for AB means what? From A to B. Okay, vector for AB means from A to B. Okay, so from A to B means what? Means, okay, A to B means from A to O, then O to B. Okay, so vector for OB means from A to O, then from O to B. Okay, can you understand? Vector for AB, A to B means A to O, O to B. Can you understand these two before I proceed?
Yes, miss.
Yes, okay, so A to O, O to B. Okay, then how we find AO? Okay, so can you see we have a vector for OA. Okay, so vector for OA is actually given as I plus J plus K. Okay, so we know that OA is actually given as I plus J plus K. So can you see AO and OA is an opposite direction. So AO is a negative of OA. Okay, remember previously I mentioned to you, with the negative sign is indicate that it is the opposite direction. So that means AO will be equals to negative of the OA. Okay, so when come to here, right? Okay, AO is negative of OA. That means I can write vector of AB as OB minus OA. Okay, OB minus OA. So, okay, with the explanations I'm giving here, okay, so next time when you want to calculate the vector for AB, right, you always remember, okay, the second one is B, so we will always take OB minus OA. You remember this. So this time I explained to you what is the reason, okay, OB minus OA. So next time you don't need to always come out from the first, then come to here. So you always remember this one. Okay, AB is actually OB minus OA. So for example, let's say BC. If you want to find the vector for BC, so that means OC minus OB. Okay, you're always using this way. Okay, now, can you tell me, how about the vectors for CA? Guys, what minus what?
Can you repeat the question?
Okay, so if let's say there's a vector for C to A, then what should I write? What minus what? What vector minus what vector? Okay, so Saad gave OA minus OC, correct? Okay, OA minus OC. Okay, yes. Okay, so then every time when we want to calculate, we just calculate in this way. Get it, guys? Okay, so we're always using this way. Okay. Okay, guys, is that okay? Any question? You need to understand this, okay? Because this is quite a simple concept. I think you learned last time also. Okay, so no questions from Saad so far. How about others? Is that okay? Okay, so hopefully I don't need to explain this concept again. So next time when you see AB, you should know that it's OB minus OA. So I don't need to explain it again. Okay, now back to the questions here. Okay, so AB is actually equals to OB minus OA. So this is OB. Okay, 2i minus j plus 3k minus with OA. This is OA. So after the subtraction, I think you know how to do subtraction, right? 2i minus I, so it's I. Minus j minus 2j. 3k minus k, which is 2k. Okay, so this is the vectors for AB. Okay, now back to the question. So you need to find the work done, right? Okay, so the work done is using the force. Okay, the work force. So this one is given by the questions, the work force. When you look at here, this one, okay, work force, and multiply with the direction. Okay, so the direction just now is obtained as this one because they told you is from A to B. Okay, then when we find the dot product, so remember how we find the dot product. Okay, so 10 times 1 for I component, then 2 times negative 2 for the J component. So for K is negative 1 times 2. Okay, so when you add it up, it's actually equals to 4. Okay, so this is the some applications on the dot product solved by using dot product. Okay. Okay, so next one. Okay, next one is about the vector product. So vector product, we also call it as a cross product. So now we come to another product. Okay, so the previous one, dot product, since we say dot, okay, so the symbol is a dot. The symbol is a dot. Dot product, symbol is a dot. Okay, so when come to cross product, the symbol is a multiplication symbol, a cross. Okay, so when come to cross product, right, why we call it as vector product? Because this time when you find the cross product, your answer will be a vector. So that's why we call it as vector product. So dot product, the answers will give you a value. So we call it as a scalar product. Okay, so according to the cross product, so cross product when OA cross product OB, two vectors, it will give you the magnitude of OA times magnitude of OB multiplied with sine theta. Okay, so just now for dot product, it's actually everything is the same here, but it's a cos theta. But here is a sine theta. Okay, but of course there's a way of the calculation. So the calculation I will be explained later. Okay, so now the theta is actually the angle between the two vectors. Okay, so the theta is referring to the two vectors. So how to calculate cross product, I will explain later. Okay, okay, so what we can understand about the vector products here. Okay, so the OA and OB, so this is referring to OA. Okay, then this is a vector for OB. Okay, so the cross product for the two vectors will give you this vector. Okay, so as I say just now, cross product will give you a vector. So give you this vector. So can you see the vectors that you obtain from the cross product is actually a vector that is 90 degree to the vector OA and vector OB. Okay, so for your information, okay, the cross product of the two vectors will give you a vector that is orthogonal or perpendicular to the two vectors, okay, to the two vectors. So for your information, okay, so if let's say you're taking the vector OA cross product with OB, then you will get vector towards the top, okay, pointing up. Then if you're taking OB cross product with OA, then you will get the vector that is pointing downwards. And of course, this vector is 90 degree with the OA and also 90 degree with the OB. Okay, so this is for your information. Okay. So, okay, actually, for this one, right, whether you get the vector going up or vector going down, there's a rules that we can use here. So, we're using our right hand. Okay, we're using our right hand. So the thumb is referring to the vector that you obtain. Okay, when you find the cross product of the two vectors. So then your fingers is actually showing the direction. Okay, so because you may need to know when OA cross product with OB, whether we get the vector is pointing up or pointing down. So can you see this is OA, right? So when we're taking OA cross product with OB, so it's just like your right hand. If you're using your right hand, okay, if you're using your right hand, so the direction of the rest of the fingers, okay, 4 fingers, okay, so it's follow that direction, okay. So can you see if you're taking OA multiplied with OB, okay, OA first, then cross product with OB, then your thumb is point up, so you get a vector going up. So if your okay, so now if you're taking the OB cross product with OA, right? Okay, then your right hand should be point down. Okay, so your thumb is towards down, so you will get a vector that is going downwards. Okay, so that is a rules. Okay, we can using right hand to actually give it the idea. Okay, so this is a right hand rules that we use. Okay. Okay, so next, okay, but when come to your content here, they are not too emphasize on all these things, okay? Just to give you an idea, okay, what you get from the cross product. Okay, now, so when come to the cross product, right, okay, so when you have a cross product for II, JJ, KK, can you see I, JJ, KK, they are parallel, okay? So the angle is actually 0, okay? The angle is 0. All these with the angle that is equal to 0. So when the two vectors are parallel, that means the angle is 0. So the cross product will be 0 as well, okay? Cross product will be 0. So as a conclusion, so when you have two vectors, you get the cross product and you get the values of 0. That means the two vectors are parallel. So that means, let's say this is a vector A, then maybe this is vector B. They are parallel, okay? So with the same steepness, okay, then the cross product will be a 0. And just now when come to dot product, when the dot product is 0, that means the vector A and B are orthogonal, 90 degree. Okay, so for this case, theta is 90 degree. So for this case, the theta is 0. Okay, okay, parallel. Okay, so how we find the cross product? Okay, so I think I'm not going to go through this one, but I'm going to show you another way of, they are showing you here how you get to calculate this one, but I don't want you to memorize this one. Okay, so let's look at here how we do the cross product. Okay, so now this one back to your determinant. Remember what do you learn for the determinant in matrix? Okay, so this is something like the 3 by 3 determinants of your matrix. Okay, so when we find the cross product for AB, we will write IJK for the first row. Okay, then can you see A come first, right? So this one is the components for the A. Okay, then second one is B, then this is a component from B. Okay, that's how we write it. Then how you find, it's like how you find the determinant. Okay, so remember when we find the determinant, what do we do? Okay, when we're using the first row, so we're taking I, then we block the first column, right? Okay, column for I. Then can you see we have A2, B2, A3, B3. Then you need to find the determinant. Then remember the second one always a minus. So we're taking the second value, minus J. Then we're blocking the second column. So we have A1, B1, A3, B3. Then the third one, we're taking K, that is a plus. So we block the third column, then we have A1, B1, A2, B2. So this is a determinant. Then you just find the determinant. That's it. Okay, so you should know how to find the determinant. A2 times A3 minus A3 times B2. Right? Okay, so you don't need to memorize. So I think if you understand this one, you know how to calculate if you can still remember what you're doing for the matrix. Okay, so maybe I will show you an example how to calculate this one. Okay. Hold on, do we have examples here? Okay. Okay, I better show you another example. Oh, 422 already. Okay, so show you how to do the cross product. Okay, now let's say I'm taking the same matrix here for the cross product. Okay, how we find the cross product? So as I say just now, the first row you are writing IJK. Then the first vector is A, so you write all the components of A. So 1I, 2J, 3K, so you write 1, 2, 3. Then for B, right, 2I minus J plus K, so you write 2 minus 1, 1. Okay, so what is the next? Okay, so remember, we're taking I, then minus J, then plus K. Okay, so for I, right, we're blocking first column. So we write 2, minus 1, 3, and 1. So for J, right, we block the second column. So we have 1, 2, 3, 1. So for K, we block the third column. So we have 1, 2, 2, negative 1. Okay, so next we just find the determinant as usual. Okay, so we have 2 times 1, 2, minus negative 1 times 3, negative 3. Okay, so this is for I. Then minus J, right? Okay, then 1 times 1, 1, minus 3 times 2, 6. Okay, this is J. Then for K, right? Okay, then negative 1 minus 4, then K. So that means our answer 2 plus 3, 5I. Then 1 minus 6, negative 5, negative, so plus 5J. Then this one, negative 5K. Okay, 5I plus 5J minus 5K. So this is the cross product. Okay, okay, for your information, the cross product for AB and BA will be different. Okay, so it's not the same as this one. Okay, but when come to dot product, it will always the same. Dot product for AB or BA is the same. Okay, so but remember, okay, if let's say come to the cross product for BA, so it's still IJK, but you will write B first, then followed by vector A. Okay, then you just calculate as usual. Okay, so for your information, when come to the cross product for BA, right, because they will give you the vector in the opposite direction. So remember, just now I say one will give you the vectors towards pointing up, so the others one pointing down, for example, right? So what you get here will be opposite sign of what you get earlier. So that means you will get minus 5I minus 5J plus 5K. Okay, the same vector but the opposite sign. Okay, so you can try to check it out later. As long as the earlier one I calculate correct, if I don't make any careless mistake, then suppose cross product for BA is actually the negative sign of this one. Okay, opposite sign of this. Okay. Next, we proceed. No, I think I give you a short break. Okay, so I give you a short break. Then we will continue for the another applications for the cross product. Okay, applications of the cross product. Okay, so 10 minutes break. Okay, guys, let's continue. So let me take the attendance first. Today, Tuesday, so is L4. In 2 hours. Okay. Take your attendance. It's supposed to be 1 absent. One more student. Okay, so Ilalam is not joining the class. Benny? Benny? Okay. Okay, so let's continue. Okay, so already done the cross product, okay, and I show you how to do the calculation, okay. So here we have 1 or 2 examples regarding the applications of the cross product, or we say vector product, okay. So look at the questions here. Determine the moment and the magnitude of the moment of a force, okay. Okay, Benny is here because you didn't take your attendance. Okay, I mark your attendance. Okay, so let's continue. Yeah, okay, determine the moment and the magnitude of the moment of a force of I plus 2J minus 3K newtons about point B having coordinates of 0, 1, 1. So point B, the coordinate is 0, 1, 1. When the force acts on a line through A, whose coordinates are 1, 3, 4. Okay, so let's look at the... Oh, hold on. Okay. Okay, so I'm trying to copy the questions here so you can refer, okay? Okay, now, so the formula, okay, the moment for the M about the points B of a force vector F has a position vector of R from A is actually given by this, okay? So there's a formula here, okay? Moment M about the point B is position vector cross product with the vector F, the force, okay? So you can refer to the questions here. Okay, the question is here. Okay, then R is a vector from B to A. Okay, so because just now they mentioned, okay, the points B and the force acts on the line through the A. So we need to find the position vector from B to A. So from B to A, that means the vector is BA. So remember just now what I say, okay? If you want to find the vector for BA, so that means you are taking OA minus OB. Okay, OA minus OB. So the OA is the vector A, right, which is 1, 3, 4. Then OB is referring to the position of the B, right? Okay, so can you see 0, 1, 1? So that means the I is 0, component J and K is 1. So minus J plus K. Okay, then we subtract it. This is what we get. Okay, I plus 2J plus 3K. So that is a position vector. the BA. Okay, then next we're taking the position vector cross product with the force vector. So force vector is already given as I plus 2j minus 3k. So let's find the cross product. So remember just now I told you the first row is ijk, then the second row is a vector for r for this case, then third row will be the vector for f. Okay, then we just get the answer. Okay, so okay, wait, this one incomplete. Okay, now, so the answers here is actually minus 12i, then this one minus 6 plus 6j. Okay, the final answer is negative 12i, then plus 6j. Okay, so k is 0. Okay, so if I write out the complete working, so it should be I minus j plus k. So for I, that means 2, 2, 3, negative 3. For j means 1, 1, 3, negative 3. For k, we have 1, 1, 2, 2. Okay? So, okay, when you find the determinant for each component, okay, so this one give you this answer, and this one giving you this one, and then for k, right, okay, come to k, can you see 2 minus 2, so it's a 0, okay, 0k, so it's a 0, so no component for k, okay, this is the answer. Okay, so this is just some example. Okay, another examples of the application for cross product. Okay, so the velocity v of point P on a body rotating with the angular velocity about a fixed axis is given by this one. Okay, velocity equals to the angular velocity cross product with the position vector. R is a point on the vector P. Okay, so as given here, that means we have to take the angular velocity cross product with the R. Okay, so this is showing another applications for the cross product. Okay, then here, after you find the cross product, so we get the velocity. So this one is a velocity, meter per second. Okay, then if you get the magnitude, okay, so the magnitude for the V, so this one is the velocity, then you get 22.89. Okay, remember how to get the magnitude, okay, square for each component. Okay, so yeah, this is application. And yep, finally, we have finished all our syllabus. Okay. Okay, so really done. Okay, so just have a quick review on what we have done today. So for today, we go through on have an introduction on the vectors in 3-dimensional. Okay, which is expressed as a component of I, j, k, which each one is a unit vectors for the x, y, z direction, which are the x, y, z axes. Okay, so how we find the unit vector, how we find the magnitude. Okay, then after that, how we calculate the angle between the two vector. Okay, by using this formula. Okay, so please take note on this formula. Okay, then next one. Okay, so I mentioned okay, so we have go through about the dot product. Okay, how we find the dot product. So it's a sum of the product for each component, that is dot product. Okay, then next one, is a cross product, or we say vector product. Okay, so for cross product, we'll give you another vector, so that's why it is called vector product. So a vector that is perpendicular to two of the vectors. Okay, And this is some things that you need to take note here, okay? When come to dot product, if the dot product give you values of 0, that means the two vectors are orthogonal, okay? So if the cross product giving you 0, that means the two vectors are parallel. That means the angle is 0, okay? Parallel means the angle between the two vectors are 0. So dot product, you get 0. Orthogonal means the angle is 90 degree, okay? Orthogonal, okay? So actually there's another way to know that the two vectors are parallel, okay? So when the two vectors are parallel, right, the vector A can be expressed as a k vector B. So the k here is referring to the scalar, okay? It's referring to the scalar, okay? So, okay, for example, let's say let's say B is actually A is actually I plus J. So vector B is actually 2I plus 2J. So vector B we can write as 2 times I plus J. So can you see vector B can be expressed as 2 scalar 2 multiplied with the vector A. So when we can write in this form, okay, or vector A is half of the scalar multiplication of the vector B, okay, then that means the A and B are parallel, same direction. Okay, so this is another way, okay, but of course you can also refer to this one, okay. Then how we find the cross product, just now we already go through the example, okay. Okay, so I already go through how to calculate this one, okay, right. Then now we still have time, about 25 minutes, oh sorry, no, yeah, 25 minutes, so we can go through the tutorial questions, not much, okay. Okay, so Saad asking when we will have our exam during exam week. Yeah, of course, okay, exam on your exam week. What is the date you get? The date is next week is the last week. You have a buffer week, right? Next week is your last week. Then you have a buffer week, I guess. Then according to my record, is actually 1st of November. Yeah, tally with the date that you have. The time is always the same. I think for all the exam, they always schedule at 2:30 to 5. Okay, so my record is the 1st of November. Yes, I can see yours also 1st of November. Students, you can check your exam date, right? Okay, so 1st of November, okay? Oh, okay. So, yeah, I remember there's a exam schedule kind of the thing in AP space. Okay, that's what I know, right? Okay. Okay, then let's continue with the tutorial question. Okay, so let's have a look with the 8A to E. So only 2 more questions to go. I think Monday I will discuss the some revision questions, exam revision questions with you. And okay, so as I say, today we'll discuss a bit of the tutorial. So Monday, I think we can go through some revision of the exam. So just in case, okay, in case I want to extend, just in case, extend the class on next Monday. Do you all okay or not? Okay, so because my next class is 5:30 lah, just in case I need to extend half an hour, can, right? Okay, so you have no more class after 4:30, I remember, because last time I scheduled the test, right? Can, huh? Okay, but I'm not so sure. Let's see how is it, okay? So if we can settle around between 2 hours, then we don't need to extend. So because if I give another additional hours, I don't think we will need much. So most probably I would rather extend a little bit. So maybe another half an hour lah. Just let you know. Okay? Okay. So yep, students say can. Okay, let's move on to the tutorial question. Okay, so you are given the vectors of P, Q, and R. They are three-dimensional vectors. Let's find the dot product. Okay, A to E are all the dot product. Let's do it now. Okay, so for the first one is a dot product for P and Q. So this one is very simple, right? 2i minus 3j for P. Then Q is, don't forget to put the dot. Then Q is 4j minus k. Okay, please take note. Can you see for vector P only two components? It's three-dimensional, but the k is a 0. So for Q is also three-dimensional, but only have component j and k. So I is a 0. So when you want to take the product, you have to be careful. Suppose the component for I times component of the I. So but the second vector do not have the I. So that means 2 multiplied with the 0, then will be 0 for I. Then plus, okay, so let's say I show you the details working. So the 2 from the first vector, but 0 from second vector. Then come to J. So from Q, we have negative 3. For second vector, we have the component J as a 4. Then come to K. First vector don't have a K, so 0. Then second vector, we have a negative 1. Okay, so that means 0 for this one and this one. Then we have negative 12. Okay, for the dot product for PQ. Be careful. Okay, so B. Dot product for R and also Q. Okay, so R is I plus 2j minus 3k. Dot product for Q, which is 4j minus k. Okay, so what do you get? As compared with your other calculation, this one consider a simple one, right? Okay, 11 for this one. Okay, I is a 0. Then j is 2 times 4. K is negative 3 times negative 1. So 3 plus 8. Yes, 11. Correct. Okay. From Cheng Hao and Sa'at. Yes, correct answer. Okay, how about C? Let me ask another student. Benny, give me the answer for dot product for RP. Benny, Benny, what is your answer for dot product for C, Benny? Benny, are you here? At least answer me as a yes. Okay, Benny not here. Okay, Ziyi,
Yes, miss.
what is the dot product for C?
Is it 2 times 2?
2 times 2. Okay, so when you get 2 times 2, can you
2J.
2J, okay, can you see when we do the dot product, the component I times component I? Okay, so for I, you have 1 I. For here, we have 2 I, so 1 times 2. Okay, so Ziyi, tell me what is a component for J? How about
2
J?
times -3.
Okay, 2 times -3, yes. How about K?
-3.
Okay, how about the second vector?
0.
Yes, 0. So since the other one is, so that means this one is 0. So you get -6 here. So what is your answer?
-4.
Yes. Okay, can you understand now?
Okay, thank you.
Okay. So now come to the next one. Okay. So for questions D, right, we have vector P dot product with vector Q plus vector R. So you need to take the sum, right? So this one is the vector Q, this one is a vector R. Okay. Now, okay, Excel, what is the sum? What is the sum of the two vectors here? Excel?
I plus 6J minus 4K.
Yes, correct. Okay. So when come to the addition, only we can only add for each component. We cannot take the component I plus the component J. So will be I plus 6J minus 4K. Okay. Then next one is a dot product. Okay. So dot product. Can I have another student? Okay. Manheng, what is a dot product? Can you tell me what multiplied by what? Manheng?
Oh, wait, miss, can you say the question again?
Here, I'm showing the question.
Okay, okay. Is it 2 minus 2 times 1?
2 minus 2.
Not minus, not minus.
Okay, Manheng, what is a component for I?
2.
2 times what?
1.
2 times 1. Okay. How about the component for J?
3 and 6.
Is it 3? Look carefully.
-3.
-3 times 6, correct.
Yeah.
So there's no K for the first vector, so it's a 0 times -4 is a 0. Okay. So what is your answer?
Yeah. -6.
Negative what? minus 18, negative 16, okay? Okay, 2 minus 18, so negative 16. Okay. Next is E. Okay, E is 2R dot product with the vector Q minus 2P. Okay, so for 2R means 2 is a scalar of multiply with the R. So R is actually I plus 2J minus 3K. Okay, so okay, we need this for our reference. So dot product with, okay, Q, which is 4J minus K, minus with 2 multiply with P. P is 2I minus 3J. Okay? Okay, so now, okay, for scalar multiplication, that means for the first part, you just need to multiply each component with number 2. Okay, so that means I have 2I plus 4J minus 6K. Okay? Okay, then come to the second bracket. Okay? So we remain the 4J minus K first. Okay? Then what we need to do is to multiply each component with 2. Okay? So, okay, minus. Okay, what should I have in the bracket? Can I have another student here? Okay, Sutej, what is the bracket? Inside the bracket, what should I write? Sutej? Sutej? What should I write inside the bracket? Okay, Sutej is not here. Okay, Wei Huan?
4I.
4I, then?
6 plus 6. J.
Plus or
minus
minus?
Minus
6J, because we don't bring in the minus, we bring in the 2. Okay? Okay. Okay, Sutej is here already. Okay, Sutej, you give the answer for the subtraction.
For the it's
Subtraction part.
10J.
10J. Okay, 10J. Then
Negative K.
Negative K. Okay.
Yeah. And minus 4I.
Minus 4I. Okay. When come to vector, it will be recommend if we follow the sequence of I, J, K. Okay. Sutej?
Yes.
Okay, so follow the sequence of I, J, K. That means it's minus 4I plus 10J minus K. Okay, so minus 4I plus 10J minus K. Okay, so now let's have a dot product. Okay, who else? Okay, Harold, dot product, please.
2 times negative 4.
Okay, then
4 times 10.
okay, next.
Negative 6 times negative 1.
Okay, final answer?
38.
38, okay. Yes, correct. Okay, thank you. Okay, so we have done until questions E. Okay, then next. Okay, wait. In second step, while 2 was multiplying, so why we didn't consider the negative sign? Okay. Okay, answer the questions from Saad. Okay. Okay. So for this part, right? If you bring in the -2, then you need to change it to addition. Okay, if you bring in the -2, then you need to write it as an addition. So that means 4j minus k plus, okay, then -4i plus 6j. So you have to be very careful. Okay, so if you bring in the -2, then here you need to change to plus. Okay, so if I don't want to change to plus, okay, I want to remain as a minus, so I just multiply by 2. Get it, Saad? Okay, you have to be careful on this one. So this is also a common error can be made by students. Okay, so next one is a F to find the angle between the vectors. Okay, so now let's continue to find the angle. So remember earlier we have gone through the formula to find the angle. So this is a formula, okay? Okay, so we are going to use this formula to find the angle, okay? So now, for the part 1, right, between vector P and vector Q. So that means your formula will be theta equals to arc cos, okay? Then what you need to do for the one at the top. At the top is a dot product of the two vectors. So since now you involve P and Q, so it's a dot product for PQ. Okay, you need to understand what you need to calculate first. Okay, then at the bottom is a magnitude of each vector. So that means the magnitude of vector P times magnitude of the vector Q. Okay, so now we need to work it out for this one. Okay, so first find the dot product for P and Q. Okay, so okay, the P is 2i minus 3j. And the Q is 4j minus k. Okay, find the dot product. Okay, so I think previously we found the PQ already, right? So PQ we get -12. Okay, so get from the earlier one is -12. Okay, next we need to find the magnitude of vector P. So remember how to find the magnitude is the square root of the sum of the square for each component. So the P, we have 2i minus 3j. So that means 2 square plus -3 square. There's no component for K. Okay, so we get square root of 2 square is 4 plus 9, so square root of 13. Okay, next one, find the magnitude of Q. Okay, so now come to another student. Okay, who else I haven't asked? Benny, Benny, are you here, Benny? Okay, no reply from Benny. Okay, Cryptocon, can you tell me how to calculate the magnitude for Q?
The 4 square plus 1 square.
Yes, okay. 1 square or negative 1 square?
Negative,
So
same.
same, yeah. Okay. 16 plus 1, 17. Huh? Okay, so next we can start to substitute into our formula. Okay, so dot product is a negative 12. Then the magnitude Q is square root of 13 times magnitude Q is square root of 17. So now let's calculate this answer and get the angle, the theta. Okay? Okay, can I have Junho calculate the theta? Okay, so waiting for your answer. Okay, so the answer given by Junho is 143.82, correct? Okay, 143.82 degree. Okay, correct. Okay, so the rest of the question is part 2 and part 3. So the way to do the calculation is exactly the same. You just involve different vector. So I want you to practice by using this formula. Okay, make sure you know how to calculate. Then I give you the answer for part 2 is 44.52. Take note. And for part 3 is 107.25. Okay, so take note on the answer. After you practice the question, then you can check your answer. Okay, so already done question 8. So only left one last question, number 9. Okay, so we will go through these questions in the next Monday class, and I will also so that means next Monday I will go through the revision. So since this is only one question, so I think 15 minutes we should able to get it done. Then I will continue with the revision for the exam. So, but I will upload the questions earlier before, okay, before the I think within this week, okay, before Monday. Okay, then any questions? Last question before I dismiss the class. Is that clear so far?
Miss,
Yes.
for number 8, right? The answer for the third one is what again?
Yeah.
Oh, okay.
Okay. Okay, then okay, so Saad already say bye-bye. Okay, then it's time for me to dismiss the class. Okay, so I will see you again. Next Monday is our last class. Okay, next Monday is our last class. Okay, bye,
Thank you,
students.
Miss.
Yeah, have a nice
Thank
day.
you, Miss.
Bye-bye. Welcome. Bye-bye.
Thank you, Miss. Have a good
Yeah.
day.